So, to begin with permutations and combinations, we must first know the fundamental principle of counting. Fundamental principle of counting. Suppose a person has 3 pants and 2 shirts. So let me denote these 3 pants available as P1, P2 and P3 and the 2 shirts as S1 and S2. Now these 3 pants P1, P2, P3 can be worn with S1 and S2. Similarly, my pant 2 can be worn with shirt S1 and S2. Now P3 can be worn with S1 and S2. So the possible pairs I have are P1 S1, P1 S2 wearing pant 1 with shirt 2nd, and P2 S1 wearing pant 2 with shirt 1, P2 S2 wearing pant 2 with shirt 2. Similarly here P3 S1 and P3 S2. So these are the possible cases of wearing 3 pants and 2 shirts. The total number of cases here are 1, 2, 3, 4, 5 and 6. So there are 6 possible cases for wearing pant 1, 2 and 3 with shirt 1 and 2. So this can also be calculated as I have 3 pants available 3 and 2 shirts available 2. So I'll simply multiply 3 by 2 and I'll get 6 pairs. So our fundamental principle of counting states that if an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of these cases will be the product of m and n. So m cross n will be the order of the total number of occurrence. Now let's talk about the permutations. So permutation means arrangement. Arrangement in a definite order of a number of objects taken some or all at a time. Suppose I have a word number. So in this I have 6 alphabets. So I have to form a 3-letter word from the alphabets of this word number when repetition is not allowed. So since I have to form a 3-letter word, I will create 3 places this. So to fill this first place, I have to find a number of ways in which this place can be filled. So I have 6 alphabets available and repetition is not allowed. Means I can use one alphabet only once at a time. So to fill this place, I have all the 6 possibilities available. So this place can be filled with 6 different ways. Now for the another place, since my one of the alphabet is used, let it be n. Suppose I have filled this place with n. Now the number of alphabets left to fill this place is 1, 2, 3, 4 and 5. So this place can be filled in 5 different ways. Similarly, for the next place, my one of the alphabet is also taken. Let it be any number. So the remaining alphabets will be 4. So this place can be filled in 4 different ways. And according to the fundamental principle of counting, I will simply multiply these possible cases. I'll get 120. So there are 120 ways in which 3-letter word can be formed from the availability of these alphabets. Now when the repetition is allowed, so now I have to form a 3-letter word when repetition is allowed. So let's have 3 places. So for the first place, all the 6 letters are available. So I can fill this first place in 6 different ways. Now here repetition is allowed, means I can use same letter again and again. So to fill this second place, I have again 6 possibilities available. So this place can be filled in 6 different ways. Similarly, my third place can also be filled in 6 different ways. Simply by multiplying all of these, I get 216. So there are 216 ways in which three-letter word can be formed with the letters of the word number when repetition is allowed. The point to be noted here is all the alphabets of the word number are distinct. So this was the case when the objects were distinct. So from this we can conclude that the number of permutations of n different objects taken r at a time where our r is between 0 to n and the objects are distinct, that is, our objects do not repeat, is the number of permutations. This is n multiplied by n minus 1 multiplied by n minus 2, and it goes on till n minus, let's check it from this example. So the number of permutations here are calculated as our total number of alphabets are 6. That means our n equals to 6, and we have to see how many we are taking at a time, taken r at a time. So our r will be 3 because we are preparing a 3-letter word. So our r is 3. Now we have to write it in the form of n. That is it can be written as n multiplied by n minus 1, n is 6, multiplied by 6 minus 1, 5, which is further multiplied by n minus r plus 1. Here n is 6, 6 minus 3 plus 1, which is 4. So this is how we get the formula n minus r plus 1, which can also be denoted as NPR. So now we talk about main notation of this topic, n factorial, which is the product of first n natural numbers. So the important formula of calculating the number of permutations will be NPR, which is calculated as n factorial upon n minus r factorial. Here our r is between 0 to n. So this symbol is known as factorial. Now when the objects are not distinct, so let's consider an example, root. I have a word root where I am getting two O's. So let me consider these two O's as different. Let me denote them by O1 and O2. So the word root can be written as RO1 O2T and RO2 O1T. So the total number of permutations in which this word can be written is, see, I have 4 alphabets in the word root. So to fill the first place, I have 4 different ways of filling it, since I am considering O1 and O2 as 2 different objects. Now to fill the second place, I have 3 alphabets left. So this place can be filled in 3 different ways. Here our repetition is not allowed. Now for the next place, I have 2 alphabets left. For the next, I have only 1 left. So by multiplying these, I get the total number of ways in which this word can be arranged, that is 4 factorial. So the total number of permutations are 4 factorial when all the objects are distinct. Now here our O is repeating. So the total number of ways in which these 2 O's can be arranged is 2 factorial. So the required number of permutations in this case is total number of permutations divided by the number of ways in which the same alphabet can be repeated, that is 2 factorial. Similarly, we can have another example. Let's consider the word institute. So in this I have 2 I's, let me denote them. I is repeating twice and I have 3 T's. So my T alphabet is 3. Now I have to calculate the required number of permutation for this case. So the total number of permutations will be, the number of alphabets in the word institute are 1, 2, 3, 4, 5, 6, 7, 8, 9. Considering all these alphabets as distinct, I'll get the total number of permutations as 9 factorial. Now since my I is repeating twice, so the alphabet I can be arranged in 2 factorial different ways. Since I have 3 T's in this word, so all the T's can be arranged in 3 factorial different ways. Thus, the required number of permutation will be total permutation divided by the ways in which these repeating elements can be arranged, that is 2 factorial into 3 factorial. So, the number of permutations of n object where p objects are of the same kind and rest are different is n factorial divided by p factorial. So now let's solve a question related to permutations. So I have to calculate the value of r if 5 times of 4pr equals to 6 times of 5pr minus 1. Since we know the formula of 4pr, we write 5 as it is, multiply by 4pr can be written as 4 factorial divided by 4 minus r factorial, which is equals to 6 times of this formula, 5 factorial divided by 5 minus of r minus 1 factorial. This can further be calculated as 6 times. This can further be calculated as 5 times 4 factorial divided by 4 minus r factorial equals to 6 times of 5 factorial can be written as 5 into 4 factorial. How? See, so 5 factorial is product of first 5 natural numbers, 5 into 4 into 3 into 2 into 1, and 4 factorial is product of first 4 natural numbers, that is 4 into 3 into 2 into 1. So our 5 factorial can be written as 5 multiplied by this 4 into 3 into 2 into 1 is our 4 factorial. Now divided by 5 minus r plus 1 factorial. So this is equals to 5 times of 4 factorial upon 4 minus r factorial equals to 6 times of 5 times 4 factorial upon 6 minus r factorial. So our 5 into 4 factorial is cancelled by here and we get 1 upon 4 minus r factorial equals to 6 upon, now our 6 minus r factorial can be written as 6 minus r multiplied by 6 minus r minus 1 factorial. We don't end it here. 6 minus r minus 1, which is multiplied by 6 minus r minus 2 factorial. Now how to know till which place we have to write this? So since we can cancel out this place, that's why we will minus it till the place we get 4 minus r factorial. So 6 minus 2 is our 4 minus r factorial. So we can cancel this term with this term and we get here is 1 equals to 6 divided by 6 minus r multiplied by 5 minus r. Now simply we can solve this equation. 6 minus r into 5 minus r equals to 6. Simple calculation is done over here. 30 minus 6 into 5, 30 minus 6r minus 5r, which will be minus 11r plus r square equals to 6. So this in further can be written as r square minus 11r plus 24 equals to 0. So by splitting the middle term, this term can be solved, which is as follows: r fixed square minus 8r minus 3r plus 24 equals to 0. So r into r minus 8 minus 3 into r minus 8 equals to 0. From here we get our r equals to 8 and r equals to 3. This is our required answer.